All right, I'm going to call this video Why Arduino Sucks. Okay, so I got a couple Arduino boards here, and this little 6-pin header at the end of the board is where SPI is. Well, SPI is a chip-to-chip communications bus that works really nicely for sending a lot of data to a lot of chips, and you could pick off chip selects from the other pins here. So I'm trying to build a thermostat for Home Assistant, and the first thing I got was this Ethernet shield, and it works great. It has a connection for the SPI, but when I hook it up here, hooks in. Okay, plugs in very nicely. Great. However, there's no wire wrap pins that come through, and so my SPI bus ends there, which is frustrating because I got a couple of display shields. There's a nice Adafruit one. And I wouldn't expect the display shield to have pins that go through, because if you put something on top of the shield, you're not going to be able to see the display. So this is a fun little Adafruit color display, and it seems to work very well, but the Adafruit documentation on their webpage was kind of lacking, and it took me a while to figure out that the examples that they point to don't actually work with this board because of this seesaw so-called chip that they have on there. So that would plug in, but I couldn't use it with this Ethernet shield because the SPI doesn't go through. So I did get these relay boards from Robot Shop, which have a connector that allows SPI to go through, but the relays are quite a bit taller than the connectors. So I got two of these, and let me pause it here. So with the relay board stacked on top of the relay board, the pins barely engage, so it won't even engage with itself. Now, you probably would never want to do this because the connections where the relays are wired into the Arduino are hardwired, and there's no way to change it. You can see them all going to these pins here, and so you couldn't actually use two relay boards together. I guess you could. You'd just be paralleling the relays because the shields have all the I/O going to the same spots. Okay, so now I've got the it's weird. I was pointing at this one and picking up the other one and going, hey, why isn't it moving? So I put the relay board, the relay boards I got from Robot Shop, on top of the Arduino, and the first thing I notice is the relay contacts touch the USB. Now that seems kind of dangerous, especially if you're going to put high voltage or something through these relays. It looks like these relays could handle 7 amps at 240 volts AC, or 10 amps at 120 volts AC. So that's a little dangerous. All right. Okay. But at least the SPI goes through, so I could add on my Ethernet shield. So I've added on my Ethernet shield, and there's one more thing I forgot to mention. There's a couple of extra pins on this relay board. I don't think they go anywhere, but they hit this capacitor. I suspect these are like for a Mega or something that's got more pins on it, a different Arduino that's got more pins. But whoever, this is a late model Uno, And surely they should have known better to put those caps so close where pins would be coming down on similar shields. So that's kind of lame. Thanks, Arduino. Thanks, Mosimo. Okay, so I think I could get this to work. I probably need to trim off those leads that touch the USB, or just not use that relay. I only need 3 actually, so I could probably just not use that relay to prevent any damage to the Arduino or the external world. And hopefully I need to double check that those pins don't go anywhere so that I'm not shorting something against the cap body, which is aluminum. And then I got SPI going all the way through, so this probably will work. Okay, next I'm going to compare these 3 display shields I got. This one says it's from Electro Freaks. I got it from Robot Shop as well. And this one, Robot Dine. These are just 128 by 64 graphic LCD. I see SCK, MOSI, Chip Select. These must have to use a soft SPI because there's no SPI connector on here. Nor does this one have an SPI connector. And then this Adafruit one definitely has an SPI connector. And I've actually used this one and have this one working. And it has the SPI connector. And then this is the relay board. But here's the thing I want to point out. Is this relay board has these really nice long wire wrap pins. And the display boards have really short pins. And so now with my Ethernet shield on top, if I try to use, let's say, this one, let's see what happens when I try to plug it in. I'm going to pause it. Okay, as suspected, the pins barely plug in. There's some headers here at the end. They hang on my Ethernet connector. And I don't think this is going to work. So this is a Contec Quick 240 that uses a chipKIT, and it's in a PLC type form factor case. It's thin rail mountable. It's got 6 I/O slots and 1 communication slot, and it's got Ethernet, USB, host and device, power inputs, micro SD, all in one board. This board was designed with this Arduino mess problem in mind, right? It came from the idea of trying to prototype something and just shields not plugging together well and really hard to get things to work. Like you could usually get any shield to work with an Arduino, but once you start getting 2 or 3 involved, it just becomes a mess and it's just really hard to prototype. So the idea behind the Quick 240 was instead of having 1 shield, you could have 6 shields, which we call cards, and each card slot is nearly identical, so almost any card will work in any card slot except for the communication card, which is a special slot with 3 UARTs on it. And there's also some exceptions where there's some analog pins that are preferred on some slots versus others. But for the most part, any card will work in any slot. And here's a stepper driver card. So this card would work in any slot. It's got a big slug of aluminum on the back for heat sinking. What are some other cards I have here? Just laying on my desk. This is I think we call this this is the bridge card. It's the Bay Area bridge card. It's got 2 H bridges on it for running little DC motors. And I have a optically isolated I/O card. This has 4 inputs. So each card slot has 4 connections that go to the outside. So there's 6 card slots, and so 6 times 4 is 24, and so there's 12 I/O on this slot and 12 I/O, and so it's like 4 groups of 4 4, 4, and 4, 4, 4, and 4. And so this was why we built this, to solve this sucky Arduino stacking problem. So here's the problem. Here's why I'm buying Arduinos today, because the Ethernet stack on the chipKIT boards currently suck, right? And it used to be better, better as in easier to use. There was a lot of great work was done by Keith at Digilent to make it better, but I think Digilent kind of abandoned chipKIT, and so the work kind of halted, and so it's kind of not quite there yet. So I'm going to start on a journey trying to fix the Ethernet over the next couple of weeks here for chipKIT, and hopefully get it to the point where I could use some add-on libraries like MQTT for Arduino with chipKIT boards. So thanks for playing along at home, and hopefully this saves you some dollars when trying to decide what shields you need to buy for your boards. And if I learn more or get more stuff working, I'll try to post it. Thanks for watching. Like and subscribe, I guess. It's the saying. It's what all the kids are saying these days.